Namaste, Jai Shri Ram. My name is Sujay K and I am working as an assistant professor in the Department of Electronics and Communication Engineering at Vivekananda College of Engineering and Technology, Kothur. So I am going to explain the halfwave rectifier with and without filter. So first I will explain the halfwave rectifier without filter circuit. So as you know, a rectifier is nothing but a circuit which converts AC into pulsating DC. Pulsating DC in the sense it is not a constant DC. So in the rectifier we have two types. One is half-wave rectifier circuit and full-wave rectifier circuit. So as you see this diagram, so this diagram is nothing but a half-wave rectifier circuit which consists of a step-down transformer and a diode and a load resistor. So the main supply voltage, which is of 230 volt, will be given to the step-down transformer. So step-down transformer is consisting of two sides. So the supply voltage will be given to the primary side, and this will be stepped down to 12 volt. So this other side is called as the secondary side. So the voltage at the secondary side is a 12 volt, which will be given to the diode. So and during the positive half cycle of the input, the diode will be forward biased. So diode will be forward biased means the diode will act as a closed switch, and the current will flow through, and it flows through the load resistor. So for the positive half cycle of the input, we get the positive output. So during the negative half cycle of the input, so the diode will act as a open switch, means there is no connection between the input side and the output side. So the current will not flow through. So the output will be, since the current won't flow through the load resistor, the output will be zero. So hence for the negative half cycle input we get a zero output. So which means that the half-wave rectifier will uses only one cycle of the input, not the complete cycle of the input. Okay. We shall see the circuit connections here. So as you see that the main supply voltage is given to the step-down transformer, and this side is a primary side where the 230 volt is given, and this side is the secondary side from where we get 12 volt AC. So this 12 volt AC will be given to the diode. So we have three terminals here. So this is 12 volt line, and this one is the ground line. So 12 volt line will be given to the diode, and the diode, the other end of the diode is connected to the resistor, which is of 1 kilo ohm, and the 0 volt line is connected to the other end of the resistor. And in order to check the output, we have used this probe. A probe is connected. To the point where the cathode of the diode and the resistor meets. So this point, and the other end is connected to the other end of the resistor. So and the probe will be connected to the oscilloscope. So when the input is given, as you see, during the positive half cycle of the input, we get a positive half cycle of the output, and during the negative half cycle we get a zero output. The reason is that diode will be reverse biased. So hence we won't get the output during the negative half cycle. So after getting this output, we need to find out the ripple factor, efficiency, and percentage of regulation. So in order to find out this value, we need to know the RMS value, and we need to know the VDC value. Okay. So in order to find out the RMS value, first we have to know the maximum voltage. Okay, so in order to know the value of the maximum voltage, so in the oscilloscope, press the measure button, and then here there are 6 options: source, counter, clear, measure all, on measure, and statistics. So in that you can see the 4th option, which is measure all. So next to that there is a button, click on that. Since it is off, you need to make it on, so click on this. So the measure button is on, and you can get the various values here. For example, maximum voltage, minimum voltage, V peak to peak voltage, RMS voltage, average voltage. So what the main value, what is required for the calculating, the finding out the RMS value is the maximum voltage, which is nothing but VR. So after getting the value of a maximum voltage, using the formula for RMS voltage, find out the RMS value, and then find out the value of V suffix DC value using the formula V suffix DC is equal to Vm by pi. So this V suffix DC value is also the full load voltage value, okay, which is required for the finding out the value of a percentage of regulation. Next, after finding out the value of ripple voltage and the output V suffix DC voltage, find out the value of a ripple factor using the formula. Ripple factor is equal to square root of Vrms divided by Vdc whole square minus 1, and then find out the efficiency value. The formula is eta is equal to V suffix DC square divided by V suffix AC square. So V suffix AC value is nothing but the Vrms value, okay, multiplied by 100, and then percentage of regulation. Find out the percentage of regulation. The formula is no load voltage minus full load voltage divided by full load voltage. So as I said already, the full load voltage can be found out. The value of the full load voltage is same as that of a V suffix DC voltage. Okay, and in order to find out the no load voltage, so what you need to do is you need to remove this. You need to disconnect this resistor, and then find out the voltage value in the oscilloscope. Okay, and after getting the value of the no load voltage, calculate the percentage of regulation. So this is for the half-wave rectifier without filter. Next, we'll see the circuit of half-wave rectifier with the filter circuit. So as you see from the oscilloscope that the output what is obtained is not a pure DC. So there is a fluctuation, or you can say there is a ripple. So we need to obtain a constant DC. So in order to obtain that constant DC, we will connect a filter. Filter is nothing but here we are going to use a capacitor which is connected in parallel to the load resistor. So let me disconnect this. So the only changes to make in the half-wave rectifier with the filter circuit is for this circuit you need to connect a capacitor parallel to this load resistor. So here you can see a capacitor which is connected in parallel to the load resistor, and remaining all the connections are same. That is, a 12 volt line will be connected to the anode of the diode, and the ground line will be connected to the other end of the resistor, and then the probe from the oscilloscope will be connected. This will be connected to the point where the cathode of the diode, resistor and the capacitor meets, to this point, and other end of the probe will be connected to the other end of the resistor. So the waveform what you are seeing is the waveform of the half-wave rectifier with the filter circuit. So again, we are not getting the constant DC, but you can say it is almost a constant DC. But there is also a ripples, as you see in the waveform. So we have to measure this the peak-to-peak value of the peak-to-peak voltage of the ripple. So in order to measure it, so in the oscilloscope, press the measure button and then click on the fourth option. So measure all is off. You need to make it on. So next to that there is a button. Click on it. So after clicking on that, so you get a various value. You can see the various value here: maximum voltage, minimum voltage, and V peak to peak voltage. So this V peak to peak voltage, what you are seeing, is nothing but the ripple voltage. Okay. So note down that ripple voltage, and then and also note down the maximum voltage, that is Vm value. Okay. So after noting down this V peak to peak, which is nothing but the peak to peak voltage of the ripple, and also noting down the maximum voltage, you need to find out first the RMS voltage using the formula VR peak to peak divided by 2 into root 3 plus VDC, and VDC can be found out, the value of the VDC can be found out using the equation Vm minus VR peak to peak divided by 2. So this V suffix DC value is nothing but the full load voltage value also. Do remember that. Next, after finding out the VRMS value and V suffix DC value, find out the ripple factor using the formula. Ripple factor is equal to VRMS divided by V suffix DC minus 1. Next, after finding out the ripple factor, find out the efficiency. That is, efficiency neta is equal to V suffix DC whole square divided by V suffix AC square. So as I said already, that V suffix AC value is nothing but the VRMS value. Okay. Multiplied by 100. Next, after that, find out the percentage of regulation, which is equal to no load voltage minus full load voltage divided by full load voltage into 100. So the value of the full load voltage is same as that of a V suffix DC voltage, but in order to find out the no load voltage, you need to remove this, you need to disconnect this resistor, load resistor, and then measure the output voltage. Okay. So without the resistor, whatever the voltage you are getting across these two points is nothing but the no load voltage. So after getting the value of the no load voltage, find out the percentage of regulation. So this is about half-wave rectifier with that, without filters. Thank you.